Okay.
Well, welcome everybody to the Propeller 2 live forum. It is March 9th, 2 p.m. Pacific, and today we have a whole variety of topics, and you're looking at my desktop and a number of hardware bits that I've been using for the quick bites when I get to do the best job of all and run other people's code. So we have a lot of topics today. First, we'll do just a little bit of housekeeping. Tomorrow at 3 p.m., if you want to join, Johnny Mac is talking about stepper motors, and I'm going to paste the registration link right now into the chat. So that first link is registration, and then the next two are the bits and pieces if you want them, which are available pretty much everywhere. So that's 3 p.m. tomorrow. And I think a lot of people will be joining because we've sold a lot of these Pololu stepper drivers and sent, I don't know, many out in the last month, and we had a lot of time to get the hardware out to people. And saw this on Twitter. This is a coaster, a P1 coaster, the QFP part. And then yesterday, you may have noticed in my junk email, I was talking about the micro SD card adapter, and this is how they looked on Monday when they were still in a panel. I think we have 50 up there, I'm not sure. And then today, they are in stock. So they'll plug right into your Johnny Mac or your P2 demo board. So feel free to come and grab one of those. I'm going to paste the links for these as well into the chat. And oh, by the way, the SD micro card add-on board is $5.95 through the duration of our meeting today. So if you want to grab one of those, and someone did place an order already for $7.95, but our salesperson was able to grab it and mark it down to $5.95 for you. So that's a good thing. So here are the two links for those things. And by the way, the P2 Edge and also the Johnny Mac board are also 10% off for just a little bit. I don't know when we're going to turn that off, but for the rest of the week, at least. So we can get more people started up on the P2. Oh, I think you've seen this before. It's so funny. We're going to have to show it again. This is Werfel's P2 developer bundle arrived with some e-waste. That's the Roy Eltham adapter. So that was funny. Okay, and
it's
also,
not my adapter.
You're there, good. If you know any teachers, this is off topic, but it's very important to Parallax. During the month of April, we're running 3 classes. We're training 300 teachers. So if you know students and students who have any kind of technology class, like maybe Kevin here, I imagine one of his teachers could use this robot, get them in our class. So there are 3 series. We're sending out 300 robots for no charge to teachers to train them through the month of April. So you can choose from the CyberBot, the ActivityBot 360, or the ShieldBot. So help us find the right teachers. Usually we fill these, unfortunately only for American teachers because we can't be sending these robots overseas because the cost of shipping and customs just gets too high. But you can buy them usually locally overseas. So today, we'll start off with a brief quick bites update, and depending on who's here and what they're ready to talk about, we can do things in this order or any other order, and I'll try to keep us moving. So quick bites, and then we have a project from Brent that I've seen that's really cool. Kevin's here with Kevin Bot. He got home from school early so he could join the P2 Live forum. Chip has a new driver for composite video. Jeff's going to show up at 2:30 to talk about Propeller tool. And Stephen is here to talk about his progress, maybe show us what he's doing with Visual Studio Code, which I got a wonderful hour from him yesterday to see how it all works and what some of the benefits are. And maybe we'll talk about Arcade too, because I see part of Team UK is here. So on the quick bites, I'm just going to paste into the chat the 2 that have most recently been posted. in case anybody wants to take a look. Okay, yeah, so the two that have been posted are from Ray, who is with us, the cheapy LCD driver, which works really well, makes the best use of this 320 by 240 on-up SPI LCDs with touch interface. So that's available. And then Johnny Mac's work from the XP presentation is also posted. And then coming up next, some of the quick bites include configuring Visual Studio for P2 programming, SD card boot up, and then a driver, and then chips, composite driver, and then the stepper motor. So I'm not sure what order these will get done, but of course you'll be able to harvest all the resources from the forums in the meantime anyway. How about if we kick this off? Kevin, do you want to show us where you are with your bot? Are you ready? You could unmute yourself.
Yeah, it'll be ready in a couple minutes, right?
Okay.
It's running the wrong code now.
Okay, you can just send me a message when you're ready to go. How about Brent? Are you available?
Yeah, I'm ready, Ken. Can you hear me?
Yeah, great.
Hey, can you share out the YouTube videos real quick? And I'll just have you kind of run those YouTubes, and then if you can do the pictures, I can just talk through some stuff.
Yep. So let me go get a link to the YouTube video. And I'll post that. So while I go find that, if you'd like to, this is his project, so you can start talking about that. I'll retrieve the video link. Okay, actually, I'll get started. So if you go to YouTube and you type in P2 darts.
Yep.
All right, and I've got the link here. I'm going to paste it in chat. And I can also show it for those that don't want to go over there. I'll share the screen on that video right now. Okay, here it is. I'll reset it. And I don't know if the audio is set up to come through or not for people. The sounds are great. If people can hear them or not, I don't know.
I don't think the sound's coming through.
Yeah, I'm hoping they can.
We're not hearing any sounds.
Okay, so I put the link in the chat, and this will give you the full experience.
I heard the sounds. They were just very quiet. Just turn them up.
Okay. Does that help?
Yes, a little bit.
So it's easily seen I'm not playing darts because I'll be getting the screen.
Yeah, I think we're dealing with a dart professional here.
Yeah.
Okay, so tell us about this project. Brent, do you copy?
Definitely go out to YouTube and check out the two videos that are out there because it's quite the. Can you hear me?
Yeah, we hear you now.
Can you hear me, Ken?
Yeah, it's clear.
Okay, sorry, I'm having a bad connection here too. So if I drop out, I might have to switch to a hotspot. Sorry about that.
No worries, we can come back. Okay, he might be dealing with bandwidth issues. So.
Can you hear me again, Ken?
Yeah, now you're clear.
Okay, sorry. Like I said, I'm having bad connection here, but so I'll start again. If you can go out to YouTube and watch the videos, they got really good audio with them. If you want to, can go to the picture that shows the board. That'll be a good one to start with.
Okay, I'm gonna have to bring that one up. Just a minute.
And now I'll just talk to the board and everything that's going on and give you a sense how the project works. And I can answer any questions anybody has.
Yeah, go ahead and tell us about it.
Yeah, okay, so I'm hoping to release the code later on. I just finished this up. It took me forever to get it done. So on the board, once the picture comes up, everything's done by the P2, except for the audio right now. The audio is actually done by a DF player that does the sound right now. But in the future, I want to get to have the P2 do every piece of it, which it obviously could. I just didn't have the expertise to get the player up and running, or use the P2 to get it up and running. So right now it uses a cheap DFP player to do the audio, which works really well because the P2 just sends out serial commands to it and picks which file it wants to play based on what happens with the dartboard. The project has, okay, so the dartboard is actually read by the P2. It doesn't use any of the internal workings, electronics from the dartboard. There's just two ribbon cables that come out of the dartboard, kind of like a keyboard has. And the dartboard pulls those lines each time to figure out which section of the dartboard's been read. And then it runs the code, the logic code for the darts to determine which one, what area has been hit. And then from that, it displays it up there. So I wrote the displays a custom display, completely written. I used the VG, I think Raymond wrote the driver for the VGA display, but then I used a custom renderer to do all the information to spit out the data on the displays. So that's the basic overview of how it works. Right now, those connectors you see on the screen right there, those are how it connects to the dartboard. Inside, it's just a cheap little dartboard you could buy on Amazon for like 15 bucks. There's two ribbon cables, one's kind of input, one's output. On the right side, you can see the housing that they plug into for those cables. And then I solder a male head, or header row on the other side so I can hook wires up to it. On the input side, they're driven high, use the internal 15K, inputs 15K with the resistor, and then the output, it pulls each line one at a time, it pulls it low and then reads the inputs to see if there's a match or connection pulled to ground. Then that writes a number to the hub memory, and the hub memory, once it's written to the hub memory, the dart logic will read out there and find out that it senses that something's been hit, and then it will pull that information, then decode what that number means for which zone was hit and which number was hit, and then it will run the software for the dart logic, and then lastly, it will do the results on the screen. If you want to scroll through a couple more pictures, I can talk more.
I'll go through some of the display pictures. That's the boot up screen.
If anybody has any questions too, just shout them out. I can help.
Hey, I have a few.
I'm not seeing anything. I'm seeing gray screen.
I am sharing. Anyone else see the pictures?
No.
I saw the pictures a minute ago, but not right now.
Okay, interesting.
Whatever you did to change it from the last picture to this one.
No, I'm not
failed.
seeing it either.
All right, hang on a minute. Having a little bit of Zoom challenge. Maybe I'll get it right now.
We've got you at the moment, Ken.
Okay, I think this will do it. Does that look correct?
Yeah, now we see
Yep.
pictures.
Okay. So explain about the dartboard. Is it made to be used this way, or does it have signals that normally go to a computer then, a serial port? Is that what you mentioned?
No, exactly. It's the dartboards when you open, they have their own circuit board.
Okay, any questions for Brent on this? You could put them in the chat too, or just yell them out.
Yeah, I have one.
I'm sorry, I keep getting dropped on the audio.
That's all right.
Okay, go
Yeah.
ahead.
Now, question, if a dart's hit in one section, if you hit a dart again in that same area, will it read it?
Yes, yes, because it resets each time, so it's not anything visual. It's pressure sensitive. So once it hits once, the force of the dart, comes off, and then you can hit the same zone again.
Okay, so this thing doesn't wear out then.
I'm sorry. Go ahead.
It doesn't get, I was thinking it would wear out if it had like metal contacts that you were shooting into, but there's a pressure sensor behind the dartboard, so it'll last a long time.
Yeah,
Yes, it's exactly like a keyboard. If you ever open your keyboard and it's got the plastic, that's exactly basically the same system that runs that.
So Chip, each little section is like a button.
Yes.
So
yep,
like each little blue and red section
Okay.
and each little black and white section pushes in a little bit and presses a button behind. So when the dart hits, it pushes the button and then let's go, right?
I see. Oh, that's a good way to do it.
Yep, that's exactly correct. And then as it reads them, and then just like a button, I have it debounces, so I have a pause at half second that it won't read the dartboard again. That way, because it can read multiple times, it reads fast enough as it pulls through. So that's the debounce function I use. I use a half second. So if you threw all three darts at exactly the same time at the dartboard, it's only going to read the first one that hit. It won't read any other ones. But in a normal game of darts, anytime darts, usually throw them one at a time, and a half second's more than enough time between those two.
Now, is it like a key?
What it has for the video driver, like I said, go ahead.
Yeah, on the key, like a push button, like a 9 metrics,
I heard a question.
The question I'm putting out is that ribbon cable set up like a keypad where you have the diodes reading across the columns and the rows? You know what I'm getting at? Like a keypad? Is that how
Yeah,
you
like, does it scan?
Yes, it's like a key. Yeah, it's like a keypad, but I'm using. Yes. Okay. So what it does, if you guys can hear me, I'm sorry this is breaking up really bad on my end. Is right there where this picture's at. The two bottom things are the two ribbon cables that come in. One side's input, one side's output. The inputs are all pulled high. So then on the output, they're all high on the output, and then one by one they go low, and then it reads all 8 inputs to see if it's got a 0, meaning it went to ground instead of being high. If it goes to ground, it knows that one of the zones was hit, and then it decodes what zone was hit by which input line was low at the time, and what output line was low at the time, which input line read the lowness. That makes sense.
Yeah, it's
that
just like
makes
a
sense.
matrix.
There's no diodes on it, but it does use a pull-up resistance on the input.
It's just like a matrix keyboard or the matrix switches in a pinball machine. You have
Yeah,
rows and
exactly.
columns essentially, and you scan a row and you have 8 possible inputs or whatever, and you scan the next row, so on.
Yeah, he's exactly right. 'Cause I have a pinball machine, an old 70 pinball machine. It works
Exactly.
exactly
It's
the
8
way.
by 8.
I have several old pinball machines that work this way. I've had to repair the switch matrix a few times on the oldest ones.
Very cool. Brent, thanks for bringing your project.
Hey,
Maybe-
Brent, I have a couple questions.
Yeah, no problem.
Okay, so that VGA thing, that black shell, that's just a wiring adapter to get off of the Johnny Mac board, right?
Yes, exactly. It has terminal connections on there. I don't have a breakout board, so I use it just for the it's got terminals on there so I can screw them on. Yep, exactly.
Okay. And then that little thing up on top of the breadboard, that's probably the sound player module.
Yep, that's the sound. And if it's zoomed in on there, you can see the white wire that goes from the left side off the through the pin over to it, and that's the serial connection. I only have it the one side connected because it just, I don't care what the board says back to it.
Yeah.
And that's 9600 baud that sends like 7 hex numbers to it. And one of those numbers is which file to read by numerics. So there's 1 through 25 different sound files on there. So when the board wants to play file 26, it just sends that. It sends the 6 codes, then it sends out the 26 file, and that plays the sound. And the nice thing about that sound thing is they're really cheap. It just uses an SD card for the memory for your files, and you just put them in there as like 0001 MP3, 0002 MP3, and then you can select them that. And then when you pick another song to play or another sound file to play, it shuts the other one off and plays the other one over the top of it. So you don't even have to turn them off or on necessarily. Just keep switching what sound you want to play. So,
You know, that's kind of the same idea we did for that, or that Baggers did for the like the arcade games for or what was it, Space Invaders. He just had a wave player kind of thing that you could trigger any number of channels and it would just layer them on top, and it worked pretty well. How big are your MP3s? What do they add up to?
The one that has the walk-up music, kind of the screen you see right now on with the picture is kind of the walk-up music, and that one's under I think a megabyte. But the other ones are just kind of small sound files, really, really small. I could get them onto the flash if I knew how of the memory, but that's a whole. I was running out of time to get this project done.
I understand. Yeah, no problem.
Okay, so my audio is much better on my end, so my internet's coming around, so I can probably do a much better job explaining what's going on here. So from what you're looking at here, let me start over so I can go through real quick. The board, like I said, has the players on there. I wanted to use the P2 to do everything, but like I said, I ran out of time to get that done. So I had to kind of use the MP3 player to do the sound piece. When the dartboard, like I said, it pulls the lines. It's 8 by 8 configuration. So going back to answer Chip's thing about the buttons, on the dartboard there is 62 spots that count for hits. That's why 8 by 8 works, because then it gets 64 unique spots. 2 of them aren't used, and that if you go think. And then it's called, there's a singles, and then there's the doubles are the outer rings. Those are count twice. So if you hit the top one right under that 20, that's a double 20, that counts as a 40. So that's a different zone. And then the inner small ones, those are the triple zones. So it's 20, 20, and 20 gives you 60. And then you have one for a double bullseye and one for a single bullseye gives you the 62 different zones that it detects. Now, each single spot's actually got 2 spots. They're all the the white or black ones in there, but those are connected together. So it doesn't distinguish which of the white or which of the single zones it hits. It just knows it's a single zone. And then, like I said, it reads out it's got the nice thing about the P2 or all the the propeller is the different cogs makes this project doable for me, because the timing issues. I can have a VGA display going at one time. I can be sending stuff out to the sound at one time, and I can read the dartboard on a different cog. And all I have to do is mesh it together through the hub memory, which basically I just send out when the dartboard is scanned all the time. It just continuously scans for input. And once it detects one, it writes to hub memory a number, and then the Dart logic reads that number from the hub memory. If it's not a 0, it says, hey, the dartboard's been hit. I need to decode this. So then it decodes the number, and that starts the process of running the Dart logic. And the graphic-based system took me the most time to do because I custom made all that piece. So it's tile map, it's 16 by 16 are the tiles. The display is a 640 by 480. Raymond, I think, did the video driver for it. It's the one that has the parrot bird. So that's the one I based it on. And then I'm using a screen buffer of half the screen to a top and bottom to write from the tile map, to translate the tile map into the screen buffer. So that's how it does that. Once it crosses the 240th scan line, it starts drawing the top again, or it goes in and back and forth between those two, and that's how that works.
Yeah, the graphics look really good. How much are some of those images probably like bitmaps and others you draw? Like, how did you do those nice big fonts? Are those like, you had bitmaps for each digit or something?
It's all in a bitmap file. Yeah, exactly. And okay, so I use the characters, or the bitmap file is 1024 by 288 is where I've only used about 75% of them. But if you ran it through a tile editor, because there's so many black spaces in there, and I've just kept all the graphics here. Like, think of those big numbers in the middle. I do those as one big thing. So you could actually tile base. There's a lot of just 16 by 16 black tiles in there. You could actually eliminate duplicates and really shrink it down. So, but it all fits into the hub memory for all my graphics. I don't use any of the flash memory except for, just booting up. That's the only thing that's used for. So I got it all to fit in that area. So it worked out really well. The graphic demo is just, go ahead, Chip.
No, I'll say when you're done. I mean, I'll talk when you're done.
The graphic demo, the graphic demo is, it's a simplified version right now. I want to expand on it too. It doesn't have sprites, meaning that all the tiles have to line edge to edge. So across the top, and there's 40, because that's 640 divided by 16, and there's 30 going down. And that's how it's based. In the future, I'm hoping to add sprites and some transparency. So right now you're looking at.
You seem to have lost him again.
Well, that looks pretty good.
Yeah.
With things we can do in the future, like making, fast vector font renderers, we can totally slash the memory needed for stuff like this. On the P1, we had that graphics object that just, it literally took like...
Chip, you're getting like way ahead of it.
Oh yeah, I know, but I'm just thinking that, because what you want to do is just identify the things that take the most memory for the least return and figure out ways to completely decimate those so that you keep freeing up more memory so you can put more functionality in. So the graphics would be the big place to go. But it looks really good.
Thanks, Brent. And feel free to post any of that on the forums too. I know others are going to be interested in the code for the
I'm sorry
display.
I kept cutting out on you on everything, but
that's okay. We've seen far more difficult situations the past year using Zoom.
I'm going to try getting that out soon.
Well, we're going to come over and play. I don't know where you live, but this looks like fun.
And like to go out to YouTube, watch it.
We're definitely watching it because we already got 47 views in the last
Gotcha,
minute.
no problem.
Thank you. Okay, let's do intermission. We'll switch over to Kevin and see what he's got going on now. So Kevin, you can share a screen anytime.
Yeah, I've got 7 boxes. Now, so I don't know if you can hear it, but I've got face recognition, so it's...
I need to find you, and then I need to maximize spotlight use. So I'm just searching for you right now. Oh, here we are. Okay. Might have to start this over.
Okay.
Now you're spotlighted. Okay. So what do you have here today?
I've got... Now, you might notice that if you were here before, the lights are off because the battery isn't charged, but I've got... I can put my face in front of it. Well, I'm too close to it, so it's... There it goes. Okay, so Ken, you need a spotlight so the robot can see.
Okay, here it comes. I'm going to spotlight myself for a moment. Okay, there's the whole Ken.
Okay, let's see. Oh, it's not working because I don't know how it's aligning, so I need to look at the screen.
It worked.
Thank you.
All right, everybody's got the idea?
Yeah, now I'm actually loading up. Yesterday I've actually been working on another face recognition demo where it actually tracks your face around. It doesn't say hi because it uses up too much resources, but it just tracks your face around.
So you're going to have the head turning and then the eyeballs going the direction of the recognized face?
Well, the eyeballs don't go properly yet. I probably need to figure out a way to get a propeller inside because it's 2 Arduinos for both of the eyes now. Oh. It works more than with in person, not on the screen. So I don't know if you can show it.
Yesterday we did a quick training of the robot to recognize my face, and that's why I worked today. Well, this is cool. So if you notice, Kevin's robot still sits on a 4-wheel drive skid steer, a very clunky system that really doesn't go anywhere. But as soon as I can get back to the Parallax office, we've got some goodies to send over to him to really get this thing going. So I think in the future, we're going to see it rolling. Any questions for Kevin or comments?
Yeah, it's hard to have the camera at the same time as the tracking, but there you go.
There we go, yeah.
This is absolutely cool, Kevin.
So can it follow your face? Does it see your face and know how to point?
Yeah, that's what it's doing. It works. There's different ranges on the... You can actually see right here now, there's actually a video stream that's doing. And so there's a little square around this size right here. That's where it doesn't do anything. If your face is right here, it'll move, I think, left or right. And if it's here, it'll go the other direction. If it's here, it'll go up. If it's there, it'll go down. Or if it's there, it'll do both at the same time.
That's pretty good.
Yeah, he's working on getting the eyeballs to do quicker tracking. That might be helped by the propeller, and then adding some mobility and then fixing the right arm, which has a broken servo.
Oh yeah, I forgot the right arm. The right arm has a working servo now, so I got that fixed. It's really hard to find these servos because they're not standard servos. You can tell because this one's got a metal thing around it and this one doesn't. They don't make these kind anymore.
Is that like a Dynamixel servo?
It's well, this one's a Hobby Park, the one but the new one is a DS servo, I think.
Very cool. Okay, well, we look forward to seeing more of this. Thanks for sharing it.
Yeah, thank you.
It's awesome. Okay, next up. We can do the video driver, or Stephen, if you're ready.
I am ready if you'd like me to.
Yeah, or I know Jeff is here too, and Jeff had a scheduling issue. So maybe we could do Proptool quick and then Stephen.
Okay.
All right.
Oh, that's okay. My schedule freed up. But
All right.
I can go ahead and talk now if you wanted.
Sure, if you're ready.
Sure. So can I screen share?
Yeah.
Let's see. Hopefully this works. Everybody see my prop tool here?
Yeah, looks good, Jeff.
Okay. For anybody that doesn't know, yesterday I released, I think it was yesterday, was it yesterday, Ken, that I released a new version of the Propeller tool that fixes a couple of things and enhances a couple of things. That one of the things I wanted to show was this P2 enable debug feature. I have it now working the way that I intended in the beginning. The little transitionary way that I had it working was quite annoying to some people. Sorry about that. But now the way it works is you can leave debugging enabled, and even if you have, well here, I'm going to press F10 here so you can see. Okay, so debug, it just downloaded, and here's the debug working. But if you have some code that doesn't have debug statements in it, I'm going to press F10 again. It'll go ahead and compile it, but it basically backs off and it shows you here that, hey, there were no debugs found. And it did download, but obviously there's no debug showing up on the screen. And that's still with this mode on. The previous version would prompt you saying, if your clock setting was wrong, I don't know, it would give you some error message that was annoying and you had to toggle debug mode off. So that's one thing, that was my intention, was to make it so that you could leave it on most of the time and it hopefully won't get it in the way. So here we go, again, another download. Also, something people were asking for is if I turn this off and say I close the Propeller tool and start it up the next day, it will start the way that you had it left last time. So it remembers your preference setting. So there's certainly cases where you don't want debug on, even if you're working with code that has debug statements in it. And so you can toggle that off by selecting this menu item or pressing Control D. You can see on the status bar here, it tells you what the status is. And it will, Propeller tool will always just leave it in that mode for future sessions as well. So that was one thing. And then there were some bug fixes. Sorry, I'm gonna have to go look at my notes here because I kind of forget what some of them were. Let's see. Oh yeah, there was a stalled communication error that I never was sure that it would actually show up for anybody. It was an error message I put in for a condition that I didn't experience through most of my development, but I did right at the very end. I thought it was something on my side. But lots of people were having that problem. And it turned out it was somewhat of a bogus error message. Usually happened on download of some larger code, sometimes with the Propeller 1 because the download process takes longer. And the but it was bogus in that the code would actually usually get downloaded properly to the Propeller, but the tool was timing out before the Propeller could respond saying, hey, I got everything and it's okay. So that's gone now. And sometimes it would happen even if you just like did an identify and left the window on the screen for a while, like about 5 seconds, I think was the timeout, and clicked OK, then all of a sudden you would get this annoying stalled communication error message. So that's been fixed. And let's see. The other couple of things were there were some, if you had a download failure, which would show up in the status bar here, that message would sometimes stay there even during the start of the next process, like the next successful download. So I found and fixed that problem. Also, if you do have something that does debug, let me do that again. So you can see it says compile, download successful, debugging now. If I hit escape here while I'm in the editor, it'll close the debug and it says debugging stopped. But that debugging stop message was appearing at certain times that it wasn't supposed to, even for some Propeller 1 downloads. And it just had to do with how I had that thing activated. I wasn't watching the state of things properly. So that's there. It's available for download now. Does anybody have any questions about it?
It works. I just started using it for the first time this afternoon because I thought I should use this instead of Pnut when I show something. It all works great and it's really snappy and fast. And you know, I noticed something that I know we did a long time ago, but I don't remember how it works. When you're in a pub or pry or a DAT section, it tells you how many bytes are in that thing.
Yeah, so that's the compiler generates here. Let me get to a better example here. Maybe one of these. So I'll compile this. So what he's talking about is down in this section, it says, I just compiled. Actually, I compiled and downloaded, but you can just compile. I just pressed F9 to do this. And you can click on symbols and it will give you some information about those symbols, what they actually equate to in the code. And then certain things like pub routines, it tells you this is 55 bytes of space. And that's really handy for cases where you're wondering, well, is it more optimal to write this statement this way or this other way? Or maybe I can compress this thing in memory by rearranging this code or moving something out of this routine. So you can do all kinds of little quick experiments and then just hit F9 to recompile and see what the results are. And then down here in the DAT section, it'll show you where that symbol is in the actual object itself, which is sitting out in hub memory, or in the cog if it were in the cog. Wait a second. This might not be working for P2 because it keeps saying cog NA. This one is a valid thing though. That's interesting. I was hoping we'd find at least one bug during the live demo.
Well, stand by.
Yeah, Chip told me that he was trying the Propeller tool for the first time, I think, since I've updated it to support the P2. So I was both excited and incredibly scared at the same time. But overall,
just checking to see we're awake.
I'm using the pale color scheme. It looks good. I think Roy is going to like it a lot.
So that is, let's see, how did we do that? I don't know if I have, oh, this one.
If it's not black or dark blue, I won't like it. By dark blue, I mean like barely any blue in the dark.
Head west toward Roscoe Boulevard.
Joseph is driving.
Yeah, so I don't really like the pale scheme on the monitor that I currently have. I don't know what it looks like for you. But when I first created it, I was using a different monitor, and I thought it looked decent. It was easier on the eyes. But yeah, it's there. And anybody can go play with this by just going to preferences, and they can click around here and make their own scheme as well, and then save it.
You have it as like really light pastel colors, which I think looks pretty good, but they are very subtle. But you know, when you have a big block, you can differentiate them. But what might also be good is to have a complement of this, or we have like very subtle backgrounds that are almost black, but a little bit hued. And then the text in light rather than dark.
Yeah. Yeah, I agree. I think I started experimenting with that, but wasn't really happy with the results. And the problem I was having probably was to do with the theme of the rest of the chrome around the tool, that really kind of begs to be dark when you're using a darker scheme in here. So I think to really make it work well, we need to support a dark mode.
Right.
Which I'm an oddball programmer. I love being up really early and working through the day. I think a lot of programmers tend to burn the midnight oil, so they enjoy darker color schemes more than I do.
Well, good job integrating debug, especially Jeff, and fixing the strange COM port error.
Oh, thanks.
So Jeff, is this thing ready now to like do two-way communication?
It probably could. I haven't experimented with that, but I don't. Well, I guess I can't say for sure, but I don't see anything holding it up.
Well, it's working great. It looks good. I'll start using it now. It's less than painless. It's actually kind of feels good. Usually I stick in Pnut just because I know it so well, but this is actually pretty good. So I'm going to start using this.
All right. Yeah, let me know. I know you found something with the object info display, but I kind of already knew about that it was some code that I couldn't finish up at the time.
Yeah, we'll get that later, but it's working well.
Thanks.
Well, since we're
question
talking,
for you, Jeff.
Yeah.
Yes.
Loading, if you're compiling, if you're editing in another program, like I do, and I jump across to Pnut to load it. So I press Control-O and enter, and that reloads the code. Can you do something similar in Proptool? I haven't looked.
Oh, I see. So you're editing.
I'm editing in VSC.
Let's see. So I know that you can. Yeah, actually, I don't think that there's a feature for that. You can do things like right-click and select refresh in the little integrated explorer, but that's not what you're after. You're after reloading the code from the file system. And I think what would probably be better is making it so that it just registers itself for file changes on the file system, and then automatically is aware of that and maybe notifies you, hey, this file changed underneath me. Do you want me to reload it? And I know that I experimented with that for a while, and there was some kind of issue. I think that the tool was getting flooded with a whole bunch of messages, and what I needed to do was find a way to pare it down so that the system only tells it about file system changes in these folders that, which it can hopefully update by, or base it on what files are currently open in this tool.
That's exactly it. Base it on what's open, and if the open files have been modified since they were saved, you can just automatically refresh when the app is reactivated.
Right. Yeah.
It's not an issue, Jeff, so I just wondered whether there was a facility in there, because I use I use Pnut to load, or FlexProp, but I edit in VSC.
Yeah, I can tell you, you say it's not an issue, Ray, and I agree with you, but at the same time, I can tell you're developing now for P2 versus 10, 15 years ago. I'm on shared file system all the time between different machines and switching applications. And so having them aware of the files changing underneath them is, I find, extremely useful.
Yeah.
Yeah, I tend to agree, actually, Stephen, that because I do the same thing. I just tend to, I guess, not do it that way with the Propeller tool. I sometimes end up using the Propeller tool to edit things that that I have open in other things, other editors. Like I want to do some, I want to remove a whole column of data, and it's just really easy to do that in the Propeller tool. So I guess I haven't been faced with it the other direction enough for it to bug me. So I know you said it's not an issue, but I'm going to make it an issue. I'm going to put it in the repo so I get it kind of triaged and eventually done.
There are a couple of editing. There are a couple of editing features in Proptool that are really nice, particularly the column editing. And I do copy and paste my VSC into Proptool just so I can do it.
Thanks. Yeah, I never realized I would find that so useful, but I definitely do.
Hey, Jeff,
Yes.
I know this is something Ray would bring up too, is to handle an SD card present, we need to wait longer to download. Right, Ray? Like we have to, Pnut has never done this, but there's something where we need to wait like a good second or so.
Yeah, it's under a second, but it needs to wait. It needs to have an option to wait.
So you mean during part of the download process?
Waiting for the chip to respond.
Yeah, when you do a reset, if there's a card installed, then the normal boot process will go through and check to see whether there's a card installed and whether there's a file on it to boot. And that takes something like nearly half a second. And if the code doesn't wait that long for the message to come back before it times out. So if the message comes back, the ident comes back quicker than that, take it. But if it takes that long to come back, you need to still wait for it before you say there's no prop.
Okay, so the end result is with the SD card installed, you can't download from the Propeller tool because it can't find the Propeller.
Yeah.
Okay. All right. Okay. Yep. I will note that one too. That should be really easy to change.
Yeah. Just make sure you don't have a boot file on the SD card. Because it will go and boot and then you'll wonder what's going on. I'm being caught.
Okay. Thanks. No, I wasn't aware that that was an issue.
Any more questions for Jeff? Because we have more tools to talk about. Okay. Thanks, Jeff. I pasted the link for everybody to download it too in the chat.
Okay. And I might have to, I want to see what's coming up, so I might bump out and back in because my Zoom is now acting strange.
Sorry, Jeff, I had just one question for you before you go. I just started using the debug output, which is absolutely great. Is there any way we can capture the text window and just output it to a file or something? Is that possible?
Oh, there's no way on the visual control itself, but there's a feature that Chip put into the debug system. I think it's debug log.
Yeah,
Chip,
or
do you remember?
debug log, yeah.
Yeah, so
it's in the Spin2 docs.
Yeah, if you, I believe it's just a constant that you define as a 1 or a 0 or
well, no,
true or false or
it's
something.
normally 0, and if you make it a non-zero value, it'll feed everything to a debug.log file up until that many bytes.
Oh, that's right. Yes. So you specify in the debug log constant how many bytes you want as a maximum file size for the log.
Yeah.
And then when you compile and download that code to the P2, it'll run, and the Propeller tool will, and also Pnut does this, save it in a log file called, I believe it's just debug.log. And on the Propeller tool, it always stores that in, I'm going to see if I can find it here, in your Documents Propeller tool subfolder. And I already have an issue created to, or at least a thought in my head, I can't remember if I made it an issue, to make it an option for the user to specify where that file goes. But for now, it goes to your My Documents Propeller tool folder.
Super, thank you.
You're welcome.
All right. Since Coley's here and I see Baggers is too, since we're keeping you guys up so late, do you have anything else that's really important to you in the UK?
Well, we've not made much progress on the arcade, mainly because I let the magic smoke out of my P2 Edge last week. I've solved it now by gluing the 5-volt line into my P2 Edge board, but we're swapping between the arcade board and the so the P2 Edge arcade board, swapping between that and the Johnny Mac. I inadvertently plugged the wrong power supply in, so but I ordered a couple from DigiKey the other day, and Jim just sent me one, so back up and running. So we've sort of been using Cluso's Retro Blade board to just do some work with an ILI 9341 LCD, but different to the one that Ray's been using. This is 16-bit. I don't know if you can see that. So we've got it driving in 16-bit mode. Just a little side project that we're working on. What we aim to do is these little cheap Chinese games that you can get. Well, it's an ILI 9341 LCD in there. So we're going to make a P2 handheld. So the aim is to replace the board inside one of these with a P2, drive the LCD in 16-bit mode. And Jim is currently working on driving the display from a RAM buffer.
Can you fit a P2 Edge into that thing, or is there not enough room?
No, we'll probably just spin a board out, Chip, because it is quite cramped in there. But there is a little arcade cabinet one which would fit a P2 Edge in. So there's various options, but all of these cheap little Chinese things that we bought, they all have the same LCD in there.
Interesting.
So that's what we've been working on this week, just as a bit of an aside, because I was P2-less.
Great. Well, we'll look forward to more updates on this next week or whenever.
And, hey, when you say 16-bit, you mean like 565 RGB?
That's right, yeah, 565. It's the 16-bit 8080 interface, so it uses anywhere between 19 and 21 pins, but we want that because we want the speed of being able to update the screen in real time. So Jim is, like I say, he's driving it from a RAM buffer on the P2 now, so we can start to add sprites and everything else to that.
Okay, we're gonna we need to make some kind of version of the P2 Edge that has either castellated edges or something for a 50 thousandths, what do we call that, like a dual row header.
Yeah.
That would allow you to lay that thing flat without that big fat connector in the middle of everything. And so, because it is kind of a pain to make a circuit board, you know, with the power supply and keep the impedances low. It takes Michael Mulholland, you know, a good week and a half to lay out one of those things. But
as quick as that.
Maybe it takes him longer, I don't know, but it is work because he's got 6 layers in that board, and it's just a pain.
Yeah, I must admit it would be a lot easier if we could just castellated would be good. That seems to be quite popular these days.
Yes, if we put the like a little header on there, if we can keep the profile really low, maybe like an SMT header or something, then you could swap it out if it got broken or something. So nothing's dedicated in solder.
Yeah, that'd be good. You mean a bit like the new Raspberry Pi compute module, that's got like an SMT header, hasn't it? Do you mean like that?
Maybe you mean, well, yeah, that's what we're putting on those boards, right, Ken? You're talking about like that little Pico microcontroller?
Oh no, it's the new Raspberry Pi compute module. It's got a very small SMT connector on it.
Okay.
But castellated would be fine. I mean, it's you just make it square, go right around the edge. It'd be easy enough to solder.
Okay. By the way, I don't know if we talked about it last week, but we're going to redo the power supply on the P2 Edge to get around these problems that we're having. So we're going to put 2 like all-in-one switchers on that thing that have the, not just the chip, but the diode and the inductor built in, so we don't suffer these breakage problems anymore during handling and washing. And then that'll take our voltage range from just about 5 to like 4.5 to 20 volts. So it'll be a lot more tolerant. Yeah, and then that also diffuses the matter of going to a USB-C connector, because now the round coax connector is fine. You can't go wrong. Maybe just put a full wave bridge in front of it.
You mean the barrel jack, not coax. It's not coax.
Well, coaxial, well, it is in the sense that there's an inner and an outer sleeve, right? But no, it's not like a BNC coax.
And just to clarify, that's a revision to the current P2 Edge, and there's an additional model coming with all the RAM.
Right.
Okay.
Yeah, but we got to fix this power problem, because I almost blew one up today. I had to stop and look at what was really behind the power plug.
So is this a change to the Edge board itself, or to the Johnny Mac and Mini?
To the Edge board itself.
Okay.
I think it's better to solve the problem there, because it'll just make the whole thing a lot more reliable.
Yeah, I agree. Because then the Edge, when you plug it into some other board that you guys didn't make, will be more resilient as well.
Yeah, and it'll all be switchers, so it'll be very efficient. It's not going to get hotter if you run it at 20 volts than if you run it at 5.
Yeah, I think that sort of wide voltage range is important. Definitely.
Yeah, it's better for industrial apps too.
Yeah, and automotive ones. Yeah.
Yeah. Oh, that's okay. I'll talk about that, the temperature range business.
And my cable will still be good.
Yep, we bought like a couple $1,000 worth of those that had special, like bigger than normal copper wiring in them, so they don't drop voltage.
Yeah, 18 gauge special order.
18 gauge, huh?
Yeah.
Okay, that said 20 what you had.
I think we change it to 18.
Okay.
Okay, so Chip, you're going to talk about test data, but should we do the tools first?
Yeah, do that first.
Okay.
I'll do this later.
Unless Baggers has anything to add, because he's also up late. I saw him here.
I was on mute. You hear me now, yeah?
Yeah.
Right. So, what I plan to do with the driver for the LCD is I'm going to integrate it with Chip's new TV driver, the composite out.
I just posted it on the forum, Jim, so you can go get it off there. That's like the latest. That's
the latest one, is it?
You had, but it's all cleaned up code-wise.
Yep. Okay. And what I'll be doing is I'll be going in between the lines, so it'll follow the timings of the NTSC or PAL, and then it'll blast out the line data. So whether you're using a line renderer or whatever, or just a normal bitmap, it should be able to work. And also with the little handhelds, they've got a little jack to output to TV as well, so that will still work with, it'll have TV out as well.
Good, okay.
Yeah, perfect. So for those who don't know what we're talking about, we're working towards having 8 games run on one P2 Edge at once using the board that Coley showed a few minutes ago.
Well, wait, it's this. What did Coley show a few minutes ago? That
He
was
showed
a
the
little
arcade
handheld.
board.
Yeah,
You
that's
want
the
to have
arcade.
it run on the
Right.
handheld? That's something different.
No, he showed the
that's a different
arcade
thing.
board for a moment.
Oh yeah. I've got one right here.
Yeah, that's what he's. Yeah.
Yeah, I have one thing plugged in.
So
Hey, how is the cabinet stuff coming along?
I'm putting a new motor controller in my laser cutter. So I've got the X and Y working, but just having trouble with the stops at the minute. Hopefully I get that sorted this weekend and I'll start cutting some cabinets.
Oh, so you're having an issue with your laser cutter is what you're saying?
Yeah, the controller in it was only worked on Windows XP.
Oh,
So,
yeah.
It's an old one. So I bought a new mini gerbil from Awesome Tech in Australia and put it in, and I've got the XY working fine. Just having a few problems with the stops, but yeah, I should sort it this weekend. So hopefully next week I'll have an update on that.
As for an update for the games, the games are all finished now. I've even added a couple of multiplayer games, so all like cabs can play against each other.
could you quickly list all the games by memory?
Space Invaders.
I can tell, yeah.
Space Invaders 2.
Lunar Rescue, Space Invaders 2. There's the Light Cycles game. There's the Tanks game. These are multiplayer games that you can play against each other. And Jim's going to get the rest.
Yeah, nearly there. Hold on.
Wow, you guys are
There's
really...
there's a bowling game. There's a driving game. To be honest with you, it's changed quite a lot because we keep finding ROMs that write above a certain memory address and we can't fit them in. So
because we've got 8 games in as well.
Yeah, it's been as many as 13, 14, hasn't it, Jim?
Yeah, we're down to 11 at the moment. We've got Space Invaders, Lunar Rescue, Space Invaders Part 2, Laguna Racer, Space Laser, a Maze game, Lupin 3, Top Bowler, and Light Cycles, and the tank, and Light Cycles and the tank game and drawing are all multiplayer games. Although the drawing isn't really a game, but you can all draw on each other's cabs.
So with a combination of the keys, we can go into what we call the lobby, where you can browse to see what anybody else is playing.
Yeah.
But also choose your own game.
Neat. You know, we need to take the stuff from that latest NTSC PAL driver I made, and we need to use that timing computation in that 8-way game thing so that we get the best picture possible, and then figure what's going to ultimately be better, PAL or NTSC, because those monitors will take both.
Yeah.
Yeah.
Thanks, you guys, for all your work on this. I know you put so much energy into it. Yeah, there's some clapping going on out there right now.
No, Propeller's got back to be fun again. You know, we've had a bit of a lull, and it's P2 is really exciting. You know, the debugger. We've been debugging that LCD today, and it was a godsend. It would have took us 3-4 times as long if we hadn't had that.
Yeah, especially the fact you can do it in PASM as well.
Yeah, I wasn't aware of that, and it's so super simple and easy to use. You know, if you haven't used it, use it. It's a really good tool, really good.
Hey, one other thing, Graham. One last thing, Ken. What about the sound? There's a whole matter of how to run the sound. Did you do any more experimentation on that?
I got a little Class D amplifier like you got, but the noise coming out of the P2 was well, I think it was the amplifier itself wasn't that good, and it was at that moment that I was switching between, because I was having trouble with the output from the P2, so I thought I'll switch to my other board. That's when I put the 12 volts into the Johnny Mac.
Okay, yeah.
That was my moment of shame.
Yeah, I looked up something on that little Class D amplifier, and what it actually seems to be is like a 250 kilohertz PWM.
Right. It's can't remember the model number I've got. It's a PDA something or other. Need to find the board, but yeah, I think for the small cabs that we're using, these little LM386s are perfectly adequate. I know you're a bit of an audiophile, Chip, so you want the sound quality to be brilliant. And I think for driving, you know, if you're something like Johan's mod player, yeah, you would want a decent set of speakers and what have you. But for the arcade cabs, just these little LM386 boards will be absolutely fine.
Okay.
Enough to drive a couple of speakers without being too loud either, because remember there's going to be 8 of them, and they'll all be in close proximity to each other. So I'm going to flip where the speakers are, flip them so they're forward facing anyway. So we'll get the maximum out of them.
All right, and those aren't going to modulate the power lines badly or anything.
No, I don't think so. No. And if they do, we can always switch to that. What you said, put the amplifier by the arcade board. I don't think we'll need to. If we use a good quality cable, I think we'll be fine. We're not going to be running. I'd say 2 meters will be maximum.
Okay.
So yeah, I think it'll be okay.
Graham, if you're here next week, show the cool graphics too that you came up with.
Yes. Well, it wasn't me actually. It was another forum member, one of Jim's friends, Andy, and we had a couple of ideas. Yeah, he was here on the last call. Yeah, I'll see if I can find it, and I'll before the end of this.
Okay, we can jump back to you. Yeah. All right, great. Thanks, guys. Team UK has a good showing here. Stephen, shall we talk VSC? All right, this is a chance to win over Ray with new color schemes.
Hey, Ray, I got this. I did this for you, Ray. Okay, I'm going to share a screen. What I'm working on while I'm making this happen here is Visual Studio Code highlighting of our spin code. And this semantic highlighting understands the different variables and what they are, and can now color things appropriately. And so, can you all see this?
Mm-hmm.
Yep.
Okay, so you see, you'll notice this is mostly pastels, Ray, so let me know if you like it. I'm looking for advice on coloring right now, but the reason for distinguishing between color is purpose and location of the symbols themselves. And so let's take a look at this. Our objects are here, constants are here, the enums are here, right? Numeric values are all one color. Here we see a method, and we have, I wanted to see if I could add some prize in here too. I've got, pardon me for not studying my demo beforehand, but let's talk about the important things. When you look at a method declaration, you have the method name, you have parameters, you then have return values, which are a different color, and then you have local variables, and they are a different color as well. What you see here then is the syntax highlighting or semantic highlighting now knows which ones they are and can tell you which ones you're using. When I do var data or dat data variables, it's discovered, and so the bluish, they lean towards blue and green for a reason. Variables in the dat are more blue, and variables in var are going to be more green, because variables in var are purposefully different, and we'll see if we can get to demonstrating that. So here we are with, here's your var, which leans towards green. These are essentially instance variables when you create an object, while the dat are available to all instances of that object. And so I wanted them to be colored differently so you can see which ones you're dealing with when you're working here. I'm hoping these color distinctions are significant enough. They may or may not be. We'll work on that separately. The point is I had to tell it what's what so we can parse it and color it. And so you can see now when you see very little yellow, lots of blue, when you see in this case I'm indexing through objects. And so digit is an object. This is the second instance, 0 through n. And this is a method call, but here's an object, but this is a constant. And so you can see they look different. Here's screen and a constant. And so it's pretty easy to see what's going on from the colors now. How's this looking?
It looks good.
Liking it?
And you know, I'm thinking here, you know, we have some scope issue with, like, some people are disappointed that you can't have a local variable named that's also shares a name with, say, a dat variable, because it creates a conflict, which is kind of global to the object.
And that's a good thing.
That's a good thing.
It should stay that way. Do not change that.
Yeah.
Okay.
Yeah.
It's really poor programming practice to name local variables the same name as a global.
Well,
and
I
people
agree.
complaining
Yeah.
about that are doing poor programming practices that need to change their code.
Right.
Yeah, well, I was thinking, though, that with the coloring, it can be more obvious, you know?
It's
Well,
still
yeah.
really bad to have a local variable the same name as a global.
To be
Not if you
period.
did the coloring, so that
No,
the
it's
alternative-
always really bad.
No, listen to this. What if the
It's
alternative
always
between the
really
two
bad.
possible colors?
No.
Doesn't matter what color it is. It's
No, you
always
alternate.
bad.
You alternate, and then it flags to you that you have a conflict.
Yeah, no.
So it should just be a compile error and fix your code.
That's a compiler warning. No, I'm a language. I'm in language. I've been studying languages since I started my career. And some of the hardest things to debug are those kind of scope replacement, where variable declarations hide other variable declarations. That's if you think in terms of reading levels, that's kind of college level stuff. That can give you no end of problem at late night when you're less strong than you are wide awake early in the day. That's just fraught with problems. So if we can avoid going there, let's do so.
Yeah, I can attest that for me, there's been some times where I've done that accidentally, and I know not to do that.
Yes.
But I did it accidentally, and it bit me.
Yes.
Wasted a bunch of my time.
Because
majority-
Delphi permits that, right?
Yes. The
Yes.
majority of people that use compilers that allow that turn on the warnings so that you get a warning if your variable is hiding an outer variable. And they always fix all the warnings so you don't have hiding.
Yeah, in C++ land, we use that warning. It's turned on as an error all the time in our compiler. To shadow variables are bad. That's what it's called.
Right, and what's happening is you're effectively, without those warnings, you're hiding failures from yourself if you don't happen to be thinking about this. And that's the worst thing you can do when you're trying to perform quickly and solve problems quickly. It's just counterintuitive.
I'm scared, so we can move on now.
Good. So talking more then, here you see data var. Now I'm going to do something you guys maybe haven't seen before. This is where we can actually see what's being told to the highlighter.
Oh, nice.
Okay.
Yeah, that can be helpful for figuring out something.
Well, this is going to be very helpful for us developing our own themes, because it's these names that we'll be using. So method declaration static, if there's semantic information, or entity name function spin, if there's no semantic information, are the two names you use in your themes. And so this is how you tell the color of the themes. Also, you'll see that private variables are static, while public variables scope to this file, essentially, while publics are not. You'll see that declarations are here, and I tend to bold declarations. And so here's a symbol, a constant in the middle of the array spec. All right. So you can see by looking at the code, let me hide that again. You can see by looking at the code that it's telling you things about where your data lives, whether you're affecting outside of your pub or prime method, or whether it's all self-contained, and things like this. Here's, I'm just going to wander some code for a little bit. The demo guide struck me today. I was putting in some expanded feature as I'm running through the P2 OBEX, making sure that everything's highlighting well, because there's lots of different code standards in there, layout standards. And I broke something on the way, so I'm carefully selecting files that still work. I will have this released to everybody later today, within a couple hours of this talk. So here we are again, case statements, and you can see how everything is coloring. And it's quite informative. Here's all local variable work. It's all yellow. I'll probably change that. I probably want to move yellow to built-in method names so they call out better. So local variables I'll probably change and then reuse yellow, but this is the way things work for now. Here you see purples as the past parameters, the light purples. And so just by looking at the colors, you can see very clearly what the majority of your method is doing. But then you want to ask me, is there any benefit to this for spin, for PASM? So let's take a look at some PASM. Okay, so here you have constants. Here you have labels that you jump to or can reference. And then here you have the data declarations. And you'll see that I'm not doing multi-line parsing. If I were, this would probably be the blue because there's a long following this. This one, I'm not sure what I do with. But you can see now that we're actually able to, the conditionals, the right conditions, the constants, whether you're referencing data, whether you're referencing jump points or call points, is all shown now in the inline PASM. This is the DAT-born PASM. There's inline works just as well. The difference you'll see with inline is you can see the parameters, return values, and local variables being accessed in the instructions for the inline. And so you'll see the yellows and the purples and the return color greenish in the PASM code. So how's this looking?
It looks good.
This looks great.
Looks good.
Yeah, it looks great.
Excellent.
It's pretty fascinating. Now, what's interesting about this, I want to make a point. This color highlighting works if you're running Visual Studio on Windows. It works if you're running Visual Studios on Macs, and it works if you're running Visual Studio on Raspberry Pis. Also, or Linux machines. Also, if you run on a Mac and you have Raspberry Pis, you can use Visual Studio to shell over to the Raspberry Pi and run with files and folders over on the Pi from your desktop, your Windows desktop or your Mac desktop. Next week, I'll show you development on the different platforms just using Visual Studio and what it looks like. But meanwhile, this is the syntax highlighting. You have the first release of this. You'll have a later release of this later today, which will have all these changes that you're seeing here.
Stephen?
Yes.
Do you have color coding for the debug statements and its constants?
Yes, color coding for debug is kind of broken right now. You'll see in my changelog. I have to put a separate parser in there because it's, I'm not handling strings well in general, and I'm going to have to divert the parsing from looking within the strings. And so I'll probably put that in the next day or two. So you'll see that yet this week. It'll all show up correctly. So right now, debug is here. Let's see if I've got another one. I got to be careful about what I show you because sometimes it looks good.
And maybe clarify this because I tripped on it yesterday.
Okay.
Debug in terms of not CHIP's graphical features, but serial terminal.
Oh, well, okay.
PST, what do you mean by that?
Okay, the debug statements are CHIP's debug statements. And for instance, here you see the debug statement is not being parsed and not being colored. This is a debug, one of CHIP's debug statements in PASM. And you can see that it's recognizing the methods. Those will be two different colors, actually, the statement and the methods, but it's not parsing these. And accidentally, it will look inside these strings and recognize variables too. And so that has to be a separate mechanism that parses these debug statements. They'll go in pretty quickly compared to everything else I've done so far. So that's an hour or two and we'll have debug statements parsed. What I mean by this is CHIP's debug. One of the things, harkening back to something somebody said earlier, what terminal are you using and are you using the debug output? And then our guys in England said they're using debug and really enjoying it because it fits inside a PASM, as you see here, to also spin. My developer, that was Graham that was mentioning that, my development of the matrix driver has been entirely using CHIP's debug and no serial terminal for the months that I've been working on it. So just to attest, it's wonderfully powerful. So thank you, Chip.
Yeah, thanks. Well, and you're not even really using any of the graphical things, right? You're just using the text dump.
Correct. And then I actually, when I'm doing long files, you have a limit on your log files. When I'm doing long files, I just ship it by serial at 2 megabit over my Pi. And I have a Python code that interprets these statements and then writes logs and does the terminal window and stuff like this on the Raspberry Pi. And so I'll remote desktop and then do all my logging there. And I can capture, you know, tens of megabytes of logs easily from one run. And when I'm doing the matrix, I am literally doing serious amounts of debug to try and understand things. And so, yeah, it's been tremendous. So here you can see what things look like when I'm not parsing it well. This is one of the problems I created today. This is working yesterday. So you can see here that it's not referencing the object name and the constant name. It's not coloring them correctly. That's just my parser. I'm looking through where I've missed things or I've broken the parser, and I'm cleaning that up. So you're going to see new extension releases probably every couple of days for me while I work on this stuff and get it working. So after I get to a 1.0 number, then I'll ask for all of you to, if you see code that is not highlighting correctly, then, you know, send the file to me and tell me where it is, and I'll work on getting that compatible. I'll also put a template in here because this is just a parser based on statement shape. It doesn't have to be compiling. What I didn't have in time for presentation today was a short file that demonstrates all of the coloring and highlighting and something like this, so you can practice with that file to set up your own theme and do what you want. Themes are actually tiny files now that it's semantic based. So you could do a full semantic theming in under 50 lines of theme, and it's just JSON-like stuff. So it's real easy. Let me do one more screen share, and then I'll be done. And that is which file?
I have a couple comments to make whenever you're ready to.
Okay. Here is the screen share of what the code looks like for this semantic parsing. I'm basically just running through strings, identifying things. And so this is TypeScript, which is a typed language built on top of JavaScript. And so it's a TS file that you see right here. When we're talking about the syntax parsing, it's more descriptions of how to recognize regular expressions, what kind of things to recognize, and then what keyword. Remember, I showed you some of those keywords when I was highlighting on things. These are the keywords that come out when these things are recognized. So here are these, and these are the block, right? And the meta block type. And then I include constant specification, constant string. All of these are included into a pattern that fit within a data block. And so that's my semantic highlighting. Let's go one step further. This is the theme. This is what the theme looked like before for syntax highlighting. When I awakened semantic highlighting, then I add this line that says this theme can receive semantic information, so please send it. And then it looks at these descriptors, and this is the entire set for semantic highlighting. And so it has labels, variables, modifications, instances, declaration, enums, variables read-only, which are your constants, the declarations of them, and then the others, return values. Return value is new to this language, which means that it's going to have a harder time with general purpose themes because we have a little bit more semantic information. So you can use your general themes, but you might get better use out of it if you use one of our themes. And so we'll be campaigning for creating formal light and dark themes for this once we stabilize the semantic parsing. So that's what it all looks like. One of the things that you will see, I don't know what this looks like in here. Oh, thank you. I didn't need to see it that way. I'm going to not share. Anyway, I have an extensive change log, which has a list of outstanding problems. When you install the extension, you can install what you have now, and you'll have everything but PASM right now. The next version out today will give you the inline PASM and all the latest fixes since then. And every time you install a new one, please review the change log. It will tell you all the fixes that have arrived in that one. That's all I have. Questions, Ken?
Yep, or comments. We have some new people here too, so I'll go over some things that everybody may not already know, unless they've watched 200 hours of video. But yeah, in summary, Chip's compiler is Pnut, runs on Windows. This is using FlexSpin from Eric Smith that runs on Mac, Windows, and Linux. And the setup for this, I have pasted into the chat. I've also pasted a link where you can make a donation to the Iron Sheep Bank, which is Stephen's fund, as we have done at Parallax. This is very important because it gets us to other operating systems, and we need this. The setup of this we will show in a future quick bite as well, and there are setup instructions, as I mentioned, posted on Stephen's GitHub, but ours will look a little bit different. When we encounter differences between the Pnut compiler and FlexSpin, the protocol, as I understand it, since I'm going to be running all quick bytecode on both tools to see how it works, would be that we send Eric a message on his GitHub or even a zip of the code to see if he can make a compiler improvement, right?
Is he here to say for himself? But yes.
He's not, but I think is that the best way so we can keep both tools working?
Yeah, that's a general idea. There's some things that he can't do easily and probably won't do until sometime much later. But, you know, for the most part, you can get things to work on both. And there's also a bunch of stuff that FlexSpin can do that Chips doesn't do, like the preprocessor and including objects from other languages and stuff like that you will never get to run on Pnut.
Yeah, and to clarify that, Roy, you can use other languages then in VSC.
Yeah, well,
the preprocessor is that you can write in your code if underscore P2 do this, if underscore else do that. And you can use one code and write different lines into the code, and depending on those definitions, certain parts of the code get kind of removed, and then it gets thrown to the compiler.
Yeah.
So it's
just
kind
to answer Ken's question more directly, yes, FlexProp can do any of the languages intermixed with each other, and I don't know if Stephen's tested it, but VSC should be able to open any of the files. It just, his stuff is only going to syntax highlight the spin files. If you load BASIC or C files, then you'll just get default highlighting for those languages.
There are extensions, Roy, there are extensions for each of those languages.
Yeah, no, I use the C one all the time, so.
There you go. And so you can pick your favorite syntax highlighting extensions if the built-in is not satisfactory for you. So yeah, it's a wonderful environment, and it'll be an environment that essentially smooths over the collection of languages. Because now you can edit any of them, save them, compile. We have some smoothing to do in the environment right now. We're going to have to come up with a better way for identifying the top level file of what you compile. So right now it's built into the task.json file, and that's not the way to do it. So, you know, we also have issues with machine setup, and so there's absolute paths in the task file, and that's not appropriate. So, but we have to make it easy for new users to get into the environment and not have problems with where things are installed and why. And so for right now, I'm being explicit with everything. And as we develop and agree on majority-like standards of how we're setting things up, and we understand how to set up Raspberry Pi pathing and understand how to set Mac OS and Windows pathing so that the paths work, and then how to find tools via the paths at runtime. This is why I wanted to generate the task file generator, because if we can do that, then I can runtime search for things and then generate the right task definitions without hand coding those. So that's why the longer term goal is that for Visual Studio.
That's great.
And hopefully at some point in the future, the official compiler will handle pre-processing, whether it's Pnut or Ray's work.
Right, something, yeah.
Well, I found the setup to be, a few steps, but after I did it, it was fine. And now I can edit and download other Propeller 2 code perfectly well.
And I want to say, Ken, thank you for taking the time to do that, because it shows that it can be done pretty easily by someone that's not like some of us that have been doing this for a long time.
That's a nice way of putting it.
And thank you for that, because when I try and write stuff, you can imagine that I have quite a deep engineering perspective, and so I'm trying to simplify it. I'm pretty good at that in communication, verbal, when I hear things are running, not being understood, but as a written, it's a little harder for me. So I appreciate the reviews.
Yeah, you're welcome. We'll do that a few more times before we publish our quick bite too. My goal is to lower the bar of these amazing things that I see so others can use them. Not everybody's like you and the 47 other people here. Yeah. So thanks again. That was great. And I'll look forward to seeing that in the marketplace and applying the new theme too.
Thanks, Stephen.
Yes.
Very welcome.
Super work. Super work.
Yeah, it looks really good.
And
I can tell you, I'm kind of chomping at the bit now to actually write some code and see it work in progress as I'm using it. I want to write something other than TypeScript for a couple days, please.
And Chip, while you get started, here's the picture from the side of the arcade game from Coley.
Cool.
Yeah, we're probably going to change the P2 to white because I think Chip said it stands out.
Hey, Graham, it looks good the way you have it. It looks fine.
Yeah.
Yeah, no, that'll be it'll just be a vinyl print that we stick to the side of the cabs. It'll make it a little better.
So cool.
And there's 8 cogs there.
There is, yeah.
Yes.
Yeah, so that's been done by forum member Andy Spencer.
Yeah, but there is one mistake in it.
Wow.
You couldn't turn the orange one because the red and the blue one hit each other.
Well spotted.
So you have to separate the red and the blue one a little bit.
Yeah.
They hit each other and that would not turn at all. That's not good.
I was going to say that, but also the large ordinal one, the pitch on the cog isn't the same as the other, so it wouldn't mesh.
It'd be a bit rough running at best. Yeah.
It looks cool though.
I shall pass your comments on to the designer. Brilliant.
There are some European coins. They made the same mistake. They had an uneven number and or I don't know, but they had a ring of cogs, but it was a wrong number, so that couldn't turn. And it's still on that coin.
Oh, the marketing department has spoken. Okay, Chip, are you ready?
Yep. Hey, I'll talk real quick about the temperature testing we're doing. So we had our chip designed to run at 150 C junction temperature, and we were anticipating the part would be dissipating, I think it was 2.5 watts. And so with the TJA of the package being like 18 degrees C per watt, and we figured that this all fit in with an 85 degrees C ambient temperature rating. But now the part, it turns out it doesn't self-heat nearly as much as it used to. It's like half that. So the die temperature is not rising like we anticipated. So at 85 degrees C, we're not hitting 150 degrees C junction temperature. We're somewhere way below that now. So Michael's going to be doing some testing tomorrow where he's going to compute, he's going to look at he's going to use a P2 edge because the whole design was done with the idea that we would have a via stack underneath the exposed pad touching 2 square inches of copper. And that's about what we've got. So he's going to, let's see what I was saying here. He's going to heat the thing up. he's going to measure at temperature. He's going to put first a dummy load. He's going to have the P2 in reset, and he's going to put a dummy load on there and measure, like at high currents, what the efficiency of the switchers are so that we can pull them out of the equation, right? And then ultimately, he's going to run the whole thing at temperature, subtracting out what we know the switchers are taking. And then we're going to look at the temperature rise versus ambient. And we're going to try to figure out, like, you know, where we really are, because we're never going to, the part was way over designed for 150 C junction temperature. That was overkill for 85 C. So what's brought this about is we're filling out all these like columnar sheets for people like DigiKey and Mauser, and they have all these criteria that need to be filled out. And so we don't really want to say it's 175 megahertz, because in fact it's going to run a lot faster than that. But we kind of have to figure out what we can safely state, you know, at a given temperature. But I'm thinking we're going to see, because they were planning on a junction temperature of 150 C at on semi, so they did all of their engineering for that temperature, and we're never hitting that. I think not at 85 C anyway. So this means that what we'll probably do is figure out at what temperature we can run pretty high frequency, and suppose we're bumping into that 150 C, because that's truly our limit. So this was probably going to eventuate in like an upgraded temperature spec for the chip. You know, if we can keep the 175 megahertz, we can certainly upgrade the temperature without pushing on any other parameters that will draw things sideways. And then we also need to come up with, like, what's a room temperature, you know, 25 C ambient number. And we know that's easily 320 megahertz, right? We run that all the time. Anyway, he's going to be working on that stuff tomorrow.
Chip, so, you're talking about the attributes of the chip itself, right? Not how it's running on, because it's running on a P2 edge that has a lot of copper dissipating heat. You're talking about aspects of the chip, the die itself, that you're discovering now. Okay.
The thermal considerations by ON were made such that, okay, we have this exposed pad package, we have some TJA figure from Amcor that makes this special thermal package, and they say that, okay, if you have, you're going to need a via stack under the chip, so a big array of vias, and then that's going to go down to X amount of copper. So we did all of our stuff with 2 square inches of copper. So I think this thing here has just about probably very close to 2 square inches of copper. So this is like an ideal test bed. You know, this is meeting the criteria that they did all the qualifying for. So we're going to use this thing in a heat chamber. We're going to try to figure out, you know, where our corners are. And then we have to derate that, because they did all that 150 C stuff figuring on a worst case what do they call it? Process conditions, right? Where you have the worst, slowest transistors. And what we get out of the foundry is never that bad. It's better than that. So whatever we figure, we're going to have to derate by some amount to come up with a safe number that'll cover the worst case scenario, which we haven't seen yet. Anyway, this is like a long-standing question that's always been ambiguous. So he's going to try to like figure out where the edges are. And we're going to run the thing all the way to failure. You know, we're going to get it so hot. And we have this torture test program that I wrote that exercises every smart pin, every core, hub executions going on. It's like the worst case power situation. And so he's going to be running that code, you know, and then jacking the temperature up until we fail. And then also measuring along the way how much current is being drawn, backing out what we know the switcher's taking, and then we can figure out what the TGA, you know, with the TJA of 18.2, we can then work out, well, how hot is the die actually at this point? So
sounds like we're probably going to comfortably do 250 in the worst case, and probably
yeah,
higher.
Probably something
and
like that.
Probably higher for the more typical case, but worst case with high temp and voltages low and stuff like that.
Yeah,
which is what you always test for.
Right. what we need is kind of actually a curve, you know, like if you're running at this temperature, you can run this fast, or you can dissipate this much power. That's kind of what it comes to. So we need to have a curve. It's not just a simple, it's very simplistic to say you can go to this temperature at this frequency, because there's a lot more potential than that at something other than these extremely high temperatures that the chip was designed to run at.
Right. It's always worst case, like all gates firing, highest temperature, lowest voltage, still running. That's the test case.
Yeah, and we're in a really crazy situation because the chip was way over designed, you know, for temperature. Because we figured
because that first rev was really hot. Yeah.
Well, it wasn't even as bad as we thought it would be based on our tests. But then when we added the clock gating into the synthesis, the power dropped to like 40% or something, or was it 60%? It was either.
Yeah, it dropped quite a bit.
Yeah, it's like nearly halved the power. So the chip does not self-heat. So who knows? It might at 125 degrees C ambient, depending on how much current we see it taking, we can figure what is it, how much is it heating up. We might figure that the junction temperature is only 150 C. So that means it would fit like automotive temperature range. But there's always a frequency at which it can run. But we can't go lower than -40 because that gets into hold time issues that have to do with the actual layout, not just the junction temperature.
Yeah, you start running into physical problems there.
Yeah, but you know, the chip was qualified at 150 C. So we got to figure out what we can do at 150 C. Okay, I'll start talking about this, what I've prepared here. Can you guys see all this?
Yep.
Yep.
Okay, so we know there's a lot of video standards, right? This really cool thing, the TV signaling systems were really neat. And they're still useful, although maybe becoming a little less so, but I think that TVs are always gonna have a yellow RCA jack on them, just for legacy stuff. They might take component away, and they'll take VGA away, but I don't think they're gonna take this one yellow connector away. But the beauty of this system is it's one wire, it's relatively low bandwidth, and it can do, if you're looking at it, if you're projecting to a small display, you know, there's not a lot of value in super high resolution anyway. So for things like car backup cameras, this is still being used every day for new products. Anyway, here's what this signaling system looks like. And the genesis of this was in 1953. That was like 68 years ago. And do you see here, I don't know if you can see my cursor or not, but see this, there's a dip down, it comes up, and then there's this box with transitions in it. That's the color burst. Okay, that was added in 1963. Before that, the way the system worked was, let me see if I can find a scan line. I don't see a normal scan line, but what would happen is the sync would tell it when to go back to the, what would be our left side of the screen and start drawing again. This thing that has the 5 with arrows wasn't there in 1953 because there was no color. And then the level would rise up to paint, you know, the brightness level on the screen until it hit the next sync pulse. And that was black and white TV. Then in the early 70s, they added this color burst, and they had a scheme to kind of retrofit the old system so black and white TVs could still get black and white signals, but the new color TVs could decode this special color burst signal. And what that signal does is it's the color burst frequency. For an NTSC, that's 3.579 megahertz. And the TV would capture the phase. This is like a reference put out just for a brief period after the sync. And then as the Luma signal is drawn, there could be modulation at 3.579 megahertz on top, riding on the Luma signal. So you see over here where it's on the left side, there's a similar box. That is modulation. So what it would do is it would look at the phase of that very specific frequency, 3.579 megahertz, and compare it to the phase that was shown, that was delivered in the sync pulse, and it would know what hue it is. So it would kind of rotate like, you know, right around the color circle. So it's a really cool system. So we've put stuff in the chip that can handle, that can generate all this stuff, all this modulation. Down here, this is what a TV signal looks like when it does the vertical sync. You can see here that they had like a low pass filter. They probably just use an RC filter because normally you have, look at where it says like 622, 623. You have all this modulation and luma date, you know, levels up high. And then when it would start doing these serration pulses, this would kind of mix up the, what amounted to like, you know, where is the V-sync? As a PLL would grab onto this. So I do these double frequency serration pulses and then do some really low ones. See where it says 1, 2, 3? And that would generate a low edge after the RC filter, which would tell the TV to retrace back up to the top of the screen. And then by having what amounts to an overall odd whole line number of these things, you could achieve what's called interlacing, where you draw like interleave lines. First you draw the top lines, and then you come in later at half a vertical line delay, and you fill in right between every line you just drew. And so this happens at 60 hertz, so you get a total refresh in 30 hertz. Anyway, to make this all work, the timing has to be just like super precise. And for black and white, it wouldn't matter. But what has always been the bane of doing this is getting this signal, see where 5, you see the color burst reference, to get that thing to not roll against the sync signal. Because when that rolling happens, you get what's called dot crawl on your display. And I'll show you an example of what that means. So the way we do this in the P2 is we have numerically controlled oscillators to run everything, right? We have a color burst or a color space converter, which can actually generate the color burst frequency on an ongoing basis. And it can also IQ modulate the colors through this matrix equation so that it can fully generate not just the color burst little pulse when you want it, there's like 9 pulses there, but it can also modulate the luma signal to develop all the colors along the scan line. But what you don't want is that color burst phase to be rolling against your framing signals, because it creates all this. You ever seen a display that looks like, it looks like there's this kind of funny waviness over all the surfaces? That's due to dot crawl because of phase mismatch. That's like ongoing. It's always changing. So we have 32-bit NCO. So we can use an NCO to generate the color burst, and that works fine. But then the trick is to get the framing, the NCO that controls the frame timing, which is driving what are amount to like pixel periods. Because all this like sync dip here, that's all a number of absolute pixel periods. And when we get to the visible pixels, those are pixels, but this pixel timing is the common time base for everything, except the color burst. That runs, the color modulation runs independently, but you need to have the two in agreement enough that they don't have crazy like phase shifting going on perpetually, causing all this creepy dot crawl on the screen. So I'm going to pull this away from here now. So for NTSC here, the way NTSC works is it has one, it'll draw a line with one phase. Like watch, if I do a single here, see that was one scan line. There's another, and that's the same scan line, but if I'm just randomly sampling, you can see this thing's toggling 180 degrees, because on a progressive display where you're redrawing the whole frame at 60 hertz, you need to have an odd number of lines, because the funny thing about this color burst thing here, there are 227.5 cycles of those on a complete scan line, right? So if you have an odd number of lines, every time you retrace your entire screen progressively, and I don't mean interlacing, but I mean progressive scan, which is what video games use, because they need to have a fast overall update rate. If you tried to interlace video games, the action would there'd be all this serration look in the image. It wouldn't be good. So you want a 60 frame per second full update. You don't interlace, but you give it an odd number of scan lines. And so what happens is every time it redraws the same scan line, the color phase is 180 degrees from where it was the last time it drew it. Because there is some actual luma modulation that occurs along with the chroma deciphering. So by, like for example, you see when that thing drops low, in fact, you know what? I have a little draw tool here on this cool thing Ken showed me. See this here? When that thing drops low and it's happening on an actual scan line, in fact, let's go out to a scan line and we'll actually look at some real stuff here where the image is being drawn. Here we go. So this is all within a scan line right here, right? You see these sync pulses? Let me clear this. So here is our sync pulse right here. Let's see. Wait, no, I just want to draw. Here's our sync. Wait. Okay, let's say I want red. Now, why is it not drawing? I should be able to draw here. Let's not, oh, there it drew. Oh, now it won't stop drawing. Modern computers here. All right, so let's just not do that anymore. So anyway, you can see the sync pulse. So you see my little circle? There are sync pulses. Here are our color bursts. Can you guys see my pointer?
Yes.
Yes, yes.
Okay, so now when we go up here, now look up here, right? This is where some, you know, it's the level's high, so that means it's bright, and there's some modulation going on. So, oh, let me get my arm out of here. So let's go look at that. Well, look at that. See, it's like every time it redraws it, it's hitting it at 180 degrees out of phase. So it's compensating for where there was like relative darkness, right color, but a little bit of dark maybe, especially on the edges when the signal starts before it deciphers what phase it is, and it is indeed color information, not luma information. So anyway, it's kind of ingenious. By hitting it with opposite phase every time, it has this evening effect. So let me show you. I'm going to switch my big monitor here over to this thing here. Now I can aim this cool camera up here. Now look at that. Now this whole thing is sideways. Let's see. Yeah, we want to turn it like this, right? So here he is on my big screen. That little LCD doesn't do it justice. And we can see there those little squigglies. You see up here? Can you see my little cursor?
Yeah.
That's due to this funny modulation issue in NTSC where you actually see it making is it one pixel? No, it's the other. Is it one? No, it's the other. Because that is such a fast signal that it's not having enough time to like decode it as color. It should be gold, but because it's only 1 pixel thick, it kind of treats it as luma information. And anyway, PAL doesn't do this. What PAL does, and someone correct me if I'm wrong because I could be wrong, but from what I understand about PAL, this is phase alternating line. This is the system that was used in Europe, whereas what we're looking at now is NTSC. This is the something, I think it was National Television Standards Committee.
No,
Never the same color twice.
Never the same color.
Right. Oh yeah, I know. There's so many funny things. And PAL had to pay royalties to someone forever for this kind of unnecessary innovation that was supposed to improve the color, but it amounted, what was it, like $500 million of royalties over the life of PAL. So PAL in Europe was termed pay a lot. And then the Frenchies came up with their own system called CCAM, which was like Système, let's see, Système électronique couleur avec mémoire. And it was like another innovation, but some people joke that the CCAM could stand for something essentially contrary to the American method. Because I think the American method had it right the first time, you know, and no one figured out how to get more money out of it. It just worked. So anyway, we have PAL and CCAM, and all these TVs today, you know, now that we're away from CRTs and we have these big plasma displays, they all can decode NTSC as well as PAL and maybe even CCAM. CCAM was used in France and in the Middle East a lot. And then there are variations of PAL. There's PAL in South America, uses phase alternating line color signaling, but it uses NTSC frame timing.
Mm-hmm.
That's all kinds of combinations of things. So in here, I have, let me just run it. I'll run this same thing right now, but in PAL. Now watch this. Okay, I'm gonna change, this is a little driver that I made. So this is kind of small, let me make it bigger. So the first thing is NTSC or PAL. This is gonna be PAL. This is interlaced or not, and then how many total pixels on a scan line, how many of those are visible. So the total has to be about 1 1/4 greater than the visible, at least, and it needs to be an even number. And then we have, these are little shift values, like, you know, do you need to tweak it to the left or right or up or down? Anyway, so if I run this thing here, now look at this, this is interesting. We don't see those wavy lines on that little starburst anymore because I think the PAL, oh, and also what we need to do is we need to now look at the PAL signal here. Let's see. So let's go down here. Let's see, is this? There we go. Now I'll zoom in on this. And this is funny because look at this. It's not alternating because the way PAL works is it delivers color over 2 scan lines. So the next scan line is 180 degrees out of phase with this. But the really crazy thing about PAL is, unlike NTSC that has a half of a line extra per scan line of color burst, there's 227.5 color bursts in a scan line. PAL has 283.75. And you have to like flip the color reference, this thing around by 90 degrees every scan line, basically plus minus 45 degrees every scan line for it to properly decode. This took forever. I knew this a long time ago, but I forgot it because it was painful and I had to redo this all lately to get this thing working again. But I had to dive back into how all this goes. And Baggers and I were fighting this, trying to figure out why can we not get good color saturation? Well, it's because we weren't toggling the whole plus minus 45. We were doing less than that, and we're actually like not able to deliver the kind of chroma information that would have given us all the colors. So it took a while to get this thing nailed. But if we go to the next line, like notice how that's going down, right? So let's go over to the next line here. Where is it? Here. But that one's going down too, right? Or was it going up? This thing is very, very slowly shifting phase because our NCOs are not perfect. We're working with like, you know, even I can compute to the LSB, I can't completely get it out. So let's quickly go to the next one here. We saw that guy was down, this guy should be up. Oh, whoa. No, he's down too. How is this? This is PAL, right? We're in PAL. I can't explain this. In my experience, it's always been it flips. But you know what? Maybe this driver suddenly like snapped to grid a little while ago. Maybe it's actually, it's working correctly now anyway. Okay, so I can't explain why we aren't seeing a phase shift from line to line, but my experience before was it was 180 degrees out of phase. Okay, so I'll I'll go over the driver here. This is a little driver that I made. I just put it on the thing. This took me like a good week to kind of get into and figure out the math that was needed to do this right. But basically, if you remember this thing here, we have all these pieces of a scan line, right? We have like right here, I don't know if you can see my cursor, but this is like before the sync. This is during the sync. This is before the color burst, during the color burst, after the color burst. And then we have, we start drawing our visible data, and then we come back and we return. So there's all these pieces. It's like a little puzzle that all fits together. So down here at the bottom, I defined all the characteristics of PAL and NTSC. So here's NTSC up here. And they use a 3x3 matrix to take the RGB and convert it into YIQ. Y being the luma, that's like the DC level of the signal, and the I and Q form like a complex pair that becomes the modulation pattern that is superimposed on top of the Y during, output. And so NTSC calls this YIQ, and there are all these little funny numbers in here that weight the RG and B values to come up with the final Y, I, and Q. And when we get down to PAL here, they actually term it Y, U, and V. You can see down here in these names. And then what we do is we come up with all the matrix values that will feed into the color space converter. And then we have a funny thing. Here's an RGB value that actually forms the color reference that comes on in that little burst period. So this was a really hard thing to discover. FFC, that's like red, green, blue, all red, a little green. So it's kind of orange with some blue in. Well, that's like that amounts to the proper amplitude and phase that we need for the PAL so that we can toggle it plus minus 45 degrees. And then note here that the PAL frequency, instead of 3.57 like is NTSC, it's 4.433 then 618 megahertz. And here's that funny, we have 283.75 lines or cycles, color burst cycles per line. So I multiply it by 4 for handling so that we don't lose that fraction. So these are the metrics, and we have some level stuff up here for each one about where's the black level, the sync level, there's all this stuff. It was like really tedious to go through. And then down here at the bottom, we have all this timing information. And so I wanted to be able to calculate everything as good as possible. And at first I was just relying on the floating point that's single precision that's part of the compiler, that you can use for constant expressions, but it was never getting the math quite right. And if you think about it, a 32-bit float actually has only a 24-bit mantissa. So there's like 8 bits of data that were never computing. And this was causing some subtle problems that I could not stop the color burst from rolling. But what I did is I said, okay, what are all these special timings in terms of picoseconds? And that seems like overkill, but it's actually it actually helps. So here's the NTSC. So like, this is 4.7 microseconds for the sync pulse, right? And before that, we have a 1.6 microsecond rest period, and then a brief 600 nanosecond period before a 2.5 microsecond color burst period. Anyway, so what I did here is I just expressed things I didn't do any math really here. I just said, we know these numbers for sure. 3.579, that's the color burst frequency. We know there are this many cycles per line. And then I had these huge overblown numbers. So this is what the spin program uses to prepare the final parameters for the driver. So here's the driver, right? It has all these things. And these are all of the super finely computed numbers and mixed in with streamer modes that will generate the proper timing and the color burst and not have them roll against each other. Although they do roll, but it might be at like 0.001 hertz or something. It's going to be low. Here's the actual driver. But before I get there, up here, this is where I computed all the timings. So I did it super precisely. So I use this thing we have in Spin called moldiv64, which takes two 32-bit numbers unsigned, it multiplies them, and then it divides them by a 32-bit number. So this is a way that we can get all the precision possible at runtime to get a 32-bit value, and not rely on any like single precision floats that are going to not give the precision that we need. So here, remember how I multiplied the number of color burst cycles by 4? Here we compensate for that. And then I also multiply by 128 because I want to come up with a huge numerator, right? So we get a maximum precision quotient out of the equation. So 4 times 128, that's 512. Well, watch this. The reasoning behind this is this. Let's take the highest frequency between PAL and NTSC. It's 4.433618 hertz, 4.43 megahertz. If I multiply this times that 4, and then we needed to do that, but then this bonus will go now times 128. Oh, wait a minute. I got to do this in decimal. Let me start over here. 4.433618 times 4 gives us this. Then times this huge number that I want for precision gives us this monstrosity. But look at this. When I convert this to hex, it's 874D A400. So it neatly fits in 32 bits of unsigned number. So then when I divide that by something, I get a nice, like, every bit matters in the thing. And what comes out of these equations are the values that can feed the numerically controlled oscillators. And then over here, I just, I compute all the little timings for everything. This is some data that's just, is it PAL or is it NTSC? It just picks. Here I do this fraction clock freak. I take the clock frequency, which is a 3.57 or 4.43 meg for the color burst. And this gives me the term that I'm going to put into the color modulator. It's a straight term. That's pretty simple, but the trick is to get the one that feeds the streamer to be in numerical agreement. And so that's where the math gets crazy. So remember I had those big values, and I take that huge value and I look at the clock freak, and here I figure out what's the magnitude of clock freak. And I want to know how high can I jack up the numbers without rolling out of the 32-bit zone. So then I shift it up as much as possible, and I compute the fraction by taking that other big number we got and I shift it down somewhat so I get as many valid bits as possible. And then I even do this here where I add 1 to it just so that I can, and by the way, this makes double the size necessary. That could have been like 8 minus 1, but I use 7 minus 1 to get a bigger number so that when I add 1, after that's all through, I can then right shift it, effectively rounding the 32-bit integer value. So then we get super precise XF number. And that's the one that's the thing that drives the streamer's numerically controlled oscillator. And it will be in super tight agreement with this one here, which runs the color space modulator. Okay, then we go through and we calculate using picoseconds, all those things, and there's rounding in this math too. You can see here I'm shifting up by 1 before dividing, then I add 1 and shift right by 1, so I'm rounding effectively. So everything is computed. There's like no cumulative error here because of the way I did this. There's absolute error on each one, but we're getting as close as we can for the pixel that we have. And then down here I compute the visible pixel timing. And I do some debug stuff periodically just to let me see what's going on. And we compute the vertical timing, the VSync timing, and then when we're all done, when we have all that, all these variables up here set, all these, right? That's every parameter that the low-level driver needs. And it was nice to be able to compute this all in Spin. Then we go down to here and we kick off the actual driver, which is only like 70, well, let's see, we can tell here. We go to 272. That's what, 136 divided by 2 would be 68. Is that right? 68 or 72 longs. This whole thing's not much because we've done all the work by pre-computing all those constants. So we come in here and we load that parameter table into our parameters, which are a bunch of reserves back here, right? Then we grab the color palette, which is 8 bits. And I could fix this up to be 4 bits, 2 bits, and 1 bit also. Then here we set all those values into the color modulator. Remember those matrix coefficient sets? Those go in set CY, set CI, and the set CQ is done in the code because of the PAL alternating business. And then here we set the two super accurate, well, the XF is the, CF is whatever it is. XF is the one that's computed to be very accurate relative to CF. And then we make the appropriate pins outputs and DACs. And then we go into the loop here that actually renders. So the whole field loop, I'll shrink this a little bit right here, where it says field down to here, that's the entire render loop that, you know, draws every little bit of this thing. And to demonstrate this, I could say, like, let's see, let me go back. We might, let's see. If you look at the scope, what if I take out part of like, let's see, if we go down, there is a routine that it calls here called HSync. This is before sync, during sync, before color burst. So what if we like got rid of the one that's doing the before color burst? So note here, the time is now, oh my goodness, this thing won't stop drawing. There, that's our time. Okay. Now, if I download this thing, having gotten rid of that one instruction, it might shift the timing on the scope quite a bit. So, yep, let me go find it. Oops. Let's see. We're going to see some of that time, well, maybe all of that time missing. Yeah, look at that. Now it goes right into the, you know, we didn't put that piece of the puzzle in, but it's still running, but it doesn't look so hot because now we've got all this dot crawl because of these imperfect ratios. And you can see also that the that rolling there, that's when you don't have things computed correctly, you always have this rolling of the color burst reference against the frame timing. And that always causes this phenomenon. If you look at, like, let's see, you know what, this needs to go like, is it this? There we go. Yeah, you can see all that crawl action there. This is a common problem with systems. If they don't have the right timing, you get all this crawling. So if I take that thing back out and rerun this thing, oops. Yeah, now the dot crawl is gone again because we have good agreement. Though there is a little bit, I see a little bit, but that's probably below our threshold of control. Okay. There we go. Okay, so this thing, you can put in whatever X and Y you want, and it'll make a very you know, well-timed NTSC or PAL display. It does everything according to like the specification, and if you need, and it's small too. It's very small. There's this entire thing. Let's see, if I just compile, oh, it's gonna not like my debug things. Let me do this. Just cancel these out for now. If I ask it to tell me about this, yeah, the whole video driver's 852 bytes. And doesn't take much. And then let's see, was there anything I was gonna say about the render loop? This just draws, this does the before visible lines up here. This draws the visible portion and so on to build the entire, you know, field or fields if you're interlaced. And then we just have a routine here that draws blank lines, and then the thing that does the horizontal sync Oh, and right here, this is notable. For PAL here, we have to alternate on each line. So for NTSC, we just have the same value in, in this one as we do this one. So it doesn't matter for NTSC, but for PAL, it does the phase alternating line to get what's needed to make the color work right. All right, and then here I have this higher level program just exercises it. Okay, one last thing to show. I'll do this bigger file here. Let's see. So this is going to be interlaced because you see this one right here. So when I run this is like 400K of data, but let me see if I can back up with this thing enough that you can see it well. Let's see, it's a pretty decent looking image, and this is NTSC. And this image, 720 by 480. But you know, for one wire, and this will probably be around for a long time, and we have the hardware to handle it. It's just a nice, I really like this signaling system. It works well, and it's very usable.
Excellent.
It looks really good there, Chip.
Thanks. Hope that wasn't too boring. I know it was kind of dry. I saw people looking like they're getting tired, but that happens when I talk.
A lot to take in, but it was very interesting. I've worked in video systems all my working life. It's good to see a real understanding of it. You know, the thing that drew me to Propeller 1 was its video generation.
Yeah,
that's superb.
Yeah, it's a lot of fun, and it's amazing to think that 68 years ago they came up with that system, and the TV had to have something like some flip-flops in it to know what state it was in. You know, I mean, it was fairly analog, but it had a little bit of digital stuff in it too to be able to keep track of what it was doing.
In valves.
What's that?
With valves.
Valves, yeah. Yeah, they had to build the TV logic out of tubes. And those are not cheap, you know. It was, you know, to make a flip-flop would take a couple of tubes probably.
Hey Chip, can you briefly describe something that somebody noticed in your code, I think here?
Yeah.
What the frac operator does. I believe it's like the BS2's multiply divide to multiply by a simulated or an estimated.
Yeah, what it does, it takes two 32-bit numbers and divides them, but the top number has to be a little smaller than the bottom number. It has to be able to fit within the bottom number. So technically what it does is it takes the top number, adds 32 0 bits after it, and then divides it by the bottom number. So you're guaranteed to get a quotient that represents a fraction. Watch this. If I'll just do something simple here. I'll just add a little debug line right into this thing, just to show something. I'll say debug, and then we'll say unsigned hex long, show us the whole thing. And we want, let's see, how about 1 frac 2, okay? Now if I run this, oh, it was downloading that whole image, but look at this. You see here where it says 8,000, 1 frac 2 equals 8,000? If you think about it, that is everything right. What you have here is something less than 1. And this is 32 bits that are right of the decimal point, right? So 1/2 is 1 with the infinite number of zeros after it. And so we can make this, watch this, we'll put another value, and let's say like 1 frac 3. This is where it starts getting crazy. Okay. It would be lickety split, but it has to download that image. So that's 5555, right? And if we do like, you know, 2/3, That's AAAA. And here's like why floating point always looks crazy to people. Oh, what's the number 1/10? That ought to be pretty straightforward. Oh, it's 1999999. And then we could do like 7 here. This must be bad here. What would be 1/7 be? Yeah, see, there's some repetition. It's funny that if you look at that number in binary, you can do strange things like 1frac13, and you will not see hex digits repeating, but what you will see is bit patterns repeating. Well, actually, no, you can see it here at the hex level. But if we were to look at that thing in binary, just the bit patterns repeat. The period is all over the place depending on the fraction. It could be 3 bits that repeat. Yeah, see, it's like there's a pattern to that. It repeats every 1, 2, 3, 4, 5, 6, 7. Every 8 bits it seems to repeat. Or no, I don't know. I'd have to look at that. But anyway, this is really useful. Say you want to know. You want to run an NCO and you want to run it at 100 megahertz. Let's say we've got a 100 megahertz clock here. Let's say we want to run it like 13 megahertz, right? Or no, let's make it simple. Let's say 50 first. Okay, what's the value for 50 megahertz and use whatever our clock freak is, right? Which in this case is 100 megahertz. So this is going to be this 8,000 number because it's half. Is that right? Oh yeah, but it's in binary. Let me put it back in hex. Wait. Okay, so let's say we wanted 13 megahertz out of 13 megahertz out of 100 megahertz. It just gives you the value that you'd plug into the NCO. It's 2147, AE14. That's a lot better than what you'd have to do in a 6502. Because that instruction actually in PASM is a quartic instruction. The quartic can do divides and square roots and multiplies aside from the transcendentals and log and exponent. So does that make sense? Frac tells you what the 32-bit fraction is right at the decimal point. Were there any other questions?
That makes sense. Can it also be used sort of like that BS2 function, the * multiply divide, where you can represent a number that's a whole and a part that you multiply into something to another integer to get a higher resolution?
Yeah, I remember what that was. Well, we have this moldiv64, which takes 2 unsigned 32 bits, multiplies them, and then divides them by a 32-bit.
Yes,
so
sorry.
That's super flexible. That you can do a lot with that.
Yeah.
But yeah, just to ratio stuff, you can just do a straight multiply.
Yeah, understood. Thanks.
Yeah. Now I'll stop sharing here, and then we can. Let's see. I don't know if there are any other. Yeah.
I have a different question. When you have a series of objects, child objects as you go down the line, so if I've got a top level object and then a middle level object and a bottom level object, from the top, I can't call the bottom directly, can I? I can't put...
No, you can only go one layer at a time.
Is there any... Is it...
Yes, there is. Method pointers. Would that solve it for you? But you have to request the method pointer. Anybody can get a method pointer of their immediate child. Any method in an immediate child, you can get a pointer to, or you can get a pointer to your own method. But if you want to get a pointer to like a child object, you have to at least ask the child to get it for you.
Right. Okay. Yeah, because what I was trying to do, I've got this LCD driver, and I decided that the bottom level has a PASM code that runs in a cog and some routines to draw the screen in spin. The next level up calls those lower levels to do even higher level functions of the graphics. And the two of them are tailored for a specific LCD screen. So you change two sections. One you change the pins, and one you change the resolution. And then I tried to, thought, oh, well, I want to actually be smart and run two lots of that code. So I had to go in and change, because I don't have if-defs or anything, I had to go in and change those two things I have for different to drive the smaller one. So then I brought
So
a top level.
You were changing what were kind of like parameters, right?
Mm. So no, I had to make two separate sets of objects, because there's a small half a dozen lines in each of the objects that's hard coded, because it's really difficult to put all of that at the top level. So I ended up saying, okay, that's too hard. So I just did straight out copy of those two. That's great. But now I want to start the bottom level cog driver. So I want to do a cog init of the bottom level, or a cog spin at the bottom level.
Well, what's stopping you?
Well, I had to put a routine in to do it, to call the second, for the top level to call the second level to call the bottom level.
Yeah, that's shy of getting a method pointer. Well, you're gonna have to go down and get some permission anyway. You know,
yeah.
You can't see. The trouble is, the way the compiler works, it does two levels at a time, and then it stacks all those together. So it's always marrying like parents with children, or tying parents to children, and then it goes from the bottom up, right? And so it's only aware of like two levels. It's only aware during compile of parent and child. So it doesn't know what grandchild is, or what is the opposite of that.
Yeah.
Parent.
Yeah, I was just wondering whether there was a way around it. I've already done it, but I just wondered whether there was a way around it.
Ray, that's pretty classical interface forwarding for object encapsulation. Right?
Yeah.
Forwarding the lower level interface up to your owner. Up
yeah.
above.
Yeah. Yeah. That's not something that I'm real familiar with. I'm not really a high level programmer.
Well, I kind of just adopted that from from Verilog, or the hardware description languages use that. And so to me, it seemed pretty straightforward. It was like the way they encapsulated stuff. And in hardware, I guess it maybe makes a little more sense, but anyway, that's just the way it works. So the compiler, it's a limitation of the compiler having visibility only to two levels at a time.
When you think in terms of objects themselves, independent of the compiler, you're talking about the amount of coupling or cohesion between objects. And so, you know, you're trying to minimize the things objects know about each other as the general tension, right? So unless you want the interface forwarded, you don't forward it automatically, right?
Yep. Where are we up to? Because I want to ask a couple of questions on Pnut, but I think that can wait till we get to the end.
Any more questions for Chip on the video driver?
Looks really great, Chip. Thank you for that work on
Yeah, thanks, Chip. Is it officially done, do you think?
This one is, okay, oh, I want to say that, yeah, this thing is working. I mean, I could put a better wrapper on it so I could have like pre-selected modes, like, you know, here's a 256 by 192 you can call up with one parameter. That can be done. We can add 4, 2, and 1-bit mode support for it. But what I really want to do, because I took the spin interpreter and I shifted it around a little bit, I freed up the first 16 LUT locations in the spin interpreter. And so I can redesign this thing to use the resi instructions, resume interrupt, and then put it on an interrupt, like the highest priority interrupt. And I should be able to get 4, 2, and 1-bit color working inside a spin cog. So I want to do that at some point. It'd be the same math and everything behind it, but it'd be coded a little bit differently to run in an interrupt. It'd be a little more code because there's going to be lots of resume interrupt instructions sprinkled throughout, because it's just going to execute a few instructions per interrupt. But then it would be able to do this in the same cog that's running your spin program.
Assuming that that spin program that's running isn't trying to use some of that extra cog memory itself with like inline PASM and stuff like that.
Well, what I would do is I would situate the driver up out of the way so that...
Right. I mean, you're still going to have, you have a limit on how many available longs there are. So if you have this video driver in, you have less other stuff. That's all I'm saying.
That's right. And you can run other interrupts too. You could do, I mean, we could actually take that eight-way arcade machine and we could set it up so that we're doing the video on an interrupt in the same cog along with the audio, you know, a little like wave player kind of thing, and that buttons deal all running on interrupts so that you could actually compose original video games in spin on one cog and then run, you know, call them up as objects and each one runs a separate cabinet. Okay, Ray, was that it for the video, I suppose?
It was very, just while you're there, I ducked out and had a look at my TV. It's about 12 months old. It has an AV, 3.5mm audio socket, 4-pin, 4-pin rather than 3.
Vector, so left, right, and video.
Left, right, and video, and it comes with the little breakout panel plug that splits it to the red, white, and yellow. Does not have a VGA. Has half a dozen HDMI ports.
Oh, thanks for looking at that. Yeah, see, this is a beautiful system. It's been around forever. It's probably not going to go away, and it's beautiful that it takes one pin and one wire. You know, and no crazy connector, no surface mount special stuff, nothing.
Well, they're still using it on cars too for reversing cameras.
Yes.
Does that TV have component in? Because that's still fairly common on modern
TVs. No, it doesn't.
Oh, it doesn't. Yeah, new ones don't.
No, I was surprised at that. I mean,
connectors are really, they take up a lot of the real estate and make the TVs thicker, and they've been going for the thinner TVs, so that's probably why they took them out.
Yeah, yeah. There's an Ethernet connector in there. Surprise, surprise, I suppose.
It's a smart, it's probably a smart TV, so it can do internet stuff. Yeah, mine has that.
Yeah. Learn about you.
But it's a cheap, an El Cheapo TV. It's not an expensive one. So, yeah, and you can get VGA to HDMI adapters anyway. So,
and they're super
cheap. Yeah, yeah, because VGA is not going away anytime soon. There's too many PCs out there.
Yeah, VGA, I like component is awesome for TVs. And then it's a regular old NTSC PAL is good for low res stuff. But the component, you can do 1080p and analog over 3 pins. It's very simple. And then VGA is a good system.
but almost all the new TVs don't have component anymore.
I know, it's sad. Because, yep.
It did for up until a few years ago. It was like every TV had it, and now they don't.
Yeah.
So, Chip, can I ask you some Pnut questions then? Your print statement in the code, what is that doing? Is that just putting it back into another buffer?
Yeah, yeah. All that thing does is stick stuff into buffers.
Okay, so it was just an easy way to do it.
Yeah, I was building some, like for error reporting or making the list file.
Yep.
Yeah.
I've advanced further. I've got my all my registers set up as a byte array. So I'm pulling the appropriate bits in and out.
All right.
I haven't got my big data block set yet because Pascal doesn't support structures, so that's a bit of a pain. So got to kludge it in. I've gone through the instructions. I know I've got a list of what instructions you use, so I only have to worry about them. And what flags they set, so I can hopefully do that. I'm hoping that you don't do anything, too many instructions early, and rely on assembler instructions after it to not change the flags. But I guess I'll find that out shortly.
Yeah.
Next question. When you read in a file, so you go Delphi calls a thing, initialize it, then the next time it calls it, it shoved the first file in the buffers. Is that just straight ASCII text?
Yep.
Okay, so I can fill that buffer with something myself and then see that working.
Oh yeah, that's how you could test it, sure.
Yep, great.
Yeah, the only thing that's not is like the object, the OBJ, I think it's called.
Yep.
That's the memory image.
Yep.
But yeah, it's all pretty much strings except for a few little pointers and things. It's pretty apparent, I think.
Yep. Yep. Well, I've started to delve into what it's doing in there. Do you change the print routines much anymore?
Change them?
Yeah, your code, as you're developing more extensions to your code, do you change the print routines?
I don't think
I'm asking it. Maybe if I ask you, tell you why what I'm thinking. The print routines are full of jumps, and Python doesn't like